But there's many ways to do this. When we come back, we're going to use a determinant to solve this as well, which is probably more calculator based.
More?
Yeah. More calculus based. It's more calculus based. I realized I just said calculator. That's funny, when we offered the graphing calculator course here, and the kids that were struggling to get their third math credit, they would take the graphing calculator course after they were finished with math, which made no sense, but they would call it graphing calculus. I'm taking the graphing calculus course. How'd I do? This? What'd you do? How'd you prove them inverses?
I put A in the calculator.
Yep.
Put the inverse, and then turned out to be B.
And it turned out to be B. Didn't we say we could do that? And it would turn out to be B. We said we could do that. There's two ways to do this. You can multiply them together. You can put it in your calc and do an inverse. Yep. Choice is yours. If you do multiply, boys, if you do multiply, you got to multiply both ways. It's like the f of g and the g of f to prove that they're inverses of each other. So this one too, find its inverse, flip it back to a fraction. Everybody okay with this? Okay. Some things have no inverses. And it has to be a square to start with. This one's not a square, so this one's not even going to have an inverse at all. I honestly don't know how to do the inverse by hand if it's not the calculator. I never looked into doing an inverse. I'm sure when I was in high school and college, I'm sure I had to do them by hand because we didn't have calculators. But I don't remember, and it probably is not necessary that you even learn it because you have your calculator. Again, just finding the inverse. This one had solving the equations. Solving the equations, do you have to print the inverse out? No. You can just put this in your calculator and do this step. You do not have to print it out. I printed it out just in case somebody didn't know what to do with it. But all you have to do is plug this piece in your A, this piece in your B, then say a to the negative 1 times b, and you will get your solution. Remember, this is a 3 by 3. This is a 3 by 1. So yes, I can multiply them, and I will get my 3 by 1. Okay. These work with x, y's, and z's, or subscripts. x1, x2, x3. A lot of times you'll see in upper level books, you'll see subscripts. Good? You don't even have to print that thing out. I print it out just because I just print it out. This one has no inverse. The original one itself has no inverse, so you can't solve this using inverses. Doesn't mean that you might not be able to solve it. It just means that it doesn't have an inverse. Chances are it can't be solved. And this guy, a to the negative 1 times b, gives you your solution. Just another way to solve the systems of equations. When we come back, we're going to do one more way with the determinant to solve the systems of equations and Kramer's rule. And we'll do Diophantines. Diophantines I saved for the end because Diophantines, every time you do a systems of equations, for as many variables as you have, you need equations. Diophantines is an exception. We can use 3 variables, 2 equations. So we have to play around with them a little bit. It's something you probably won't remember if you take a break for 7 days and come back. So we're doing it when we come back. Questions at all on the inverses, Lily?
You know, like, is there a date for a final exam?
It's probably somewhere like around June 12th. Somewhere like that. Okay, then it's before that. Somewhere around June. Wherever the last day is, it's the week before that. And what they usually do is like they did last year. We wanted to do a separate day, and they still won't give it to us because of the way state funding works. They need instructional time to get paid for their state day. It goes against really how you test, but So they'll do like 2 days for English and math, 2 days for science and social studies, whatever they did. They'll do that again. They'll do it the same way as last year. Which I totally disagree with. But, so, just line these guys up. If you have this, I have to subtract y. 2.25x minus y equals 0. Put them in your matrix and see if you get the same exact answers. This one has decimals, so I would just leave your matrix in decimals and see if they match up. So let's see how long it takes me to put it in my calculator. My challenge. So this is, what dimension is this guy? 2 by 3. And again, if I put it in wrong, 3 by 2, it would be glaring at me. Nothing would match up, so I would just go back and re-put it in. Oops. You just have to, remember, you have to line everything up. You're going to have to fill any spaces with zeros that you have. And go to your matrix. Look how. Here. And see if you get those answers. So this tells me x should be 7.077. Y should be 15.923. I should get the same exact answers when I use my calculator. It just may mean you have to line some things up a little bit.
Hey, does it matter which way you put it in the matrix? Like, put 2.25 on top or the bottom?
No. Did it not come in the right way? Let me take a look. Well, let me print out my matrix will be upside down. Yes. You can do it separate and REF. Then you're gonna have to use REF. You're gonna have to do well, you're gonna put it all in. You want to do the inverse? You want to do the inverse? You can do the inverse. You can do the inverse.
That's fast.
You should remember what word you can try an inverse with this. Put this in and see if you put the inverse in. And put this in separate. Put this in one. Put this in the other. And multiply this inverse times this. You can use an inverse. I think that takes longer, but absolutely. Yes. We're solving these without the algebra. We're solving these in your equation, with your matrix. That's all. So I just took, and I said, don't reinvent the wheel. You already have the equations for this. So pull up your old packet and just put your equations into your matrix. Because isn't this much easier now rather than doing that whole algebra thing? When you go through this, guys, again, like for this one, if you set this one up in your matrix, how would you set this up for your matrix? How would I set this up for my matrix? I can't put those parentheses in there, right? So I would have to distribute. How would I put this in my matrix? You can put the x first. And the constant goes here. The x, the y, the constant. If I put it like this, would that matter? If I just put it that order? No, just the first one's going to come out and be my y, the second one's going to come out and be my x. Whatever way you put it in is which way it's going to come out. Again, this one I would leave in the decimal, and you can match up your decimals. So all I want you to do is play with these. The concept is it should be so much easier to put it into your calculator as matrix, right? Rather than do all this work. And you already have the equations, so don't go back and recreate them unless you don't have them. Ask your buddy if he has them, she has them, and you don't have to recreate them.